I'm not really a fan of a lot of these modern receivers just because they're extremely difficult to work on and hard to do any testing because of the way that they're constructed. You got to take the whole thing apart to do anything to them. That includes removing circuit boards, and this one is no different. Let's take a look. This is a Denon AVR2307 that was brought in for service, and I'm told it has no sound. So we'll plug it in and see whether it does anything at all. No power, and it doesn't power up. So this one has a small power supply down here is the standby, and of course the big transformer. The fact that it's not doing anything, I have to check the standby supply first and see if we're getting any standby voltages. I tell you, I was just starting to contemplate taking this whole thing apart. I started to unhook wires. I noticed that this wire here is going all the way up to the front, and it looked initially like it went into the transformer, but it doesn't. It actually goes up to this little circuit board here, and I'm looking on the front of the circuit board, and lo and behold, it goes to a switch. And it's not marked anything, it just says on off, and this one says on standby, and it's a master power switch. No! Okay, let's turn it on and see if we get anything now more than we did before. I got a standby light lighting up red, good sign. And I have lights. So we'll see if this thing, and it shuts off. So when I turn the unit on, it will light up AV receiver, and then it shuts off with a flashing standby light, which is indicating the unit's got into a shutdown mode, that something is being detected that is, there's a failed component. More than likely an output transistor. Now this unit here has got output transistors along the top here. It also has output transistors down below. And the only way to access them is to take the entire unit apart. Of course, while it's in that disassembled state, there's no way to connect it to test it. So we got to take it apart, check for bad transistors, replace any that may be bad, and then put it back together before we can even test it. But let's see what the problem is. You see what I mean? Yeah, they got this little hatch here, but what good is that? I mean, really, you can't even get at the output transistors with this, whatever this is for. The board I need to get at is underneath here. And this does not come off. This base doesn't come off. It's attached to the board. So the only way to take the base off is to take the face off, take the back off it, and take out all the screws that hold in the board. And then I can lift the base off. But of course, doing that, I'm now going to lose all of my, well, I have to take this board out here. There's another board down here that's separate. So I got to take this board out. But in order to get at that, I got to remove that board. That's everything over to as far as the heat sink here, I believe. Yeah, that's everything over to here that has to come out to get at that. So that's it. This is a huge job to take this out, because all this has to come off in order to lift this out. So as I take out the 10,000 screws that hold this thing together, you got to take out all these screws to take the back panel off. And what else is holding this on? There's a couple more screws, I'm sure. I missed some. Yep. More screws. You know, this is definitely designed never to be serviced, like most of the modern stuff that you find today. The manufacturers don't want anybody servicing them, and they make them so incredibly complex as far as just taking these things down apart to do a minor repair. You know, you're going to spend an hour taking out screws and putting everything back together just to do a very minor repair. As you can see, now I can take out these plugs, lift these other boards out, unplug now I can lift these ones out of the way, unplug these, wherever they unplug. I still have to get this board out of the way, but just to get to this point where I can lift this board out, I have to take the whole back off and take out the input, the video ports, video audio ports. I have to take all these out just so that I can get to the point where I can lift this board up. You probably wonder what's under this plate here, right? Absolutely nothing. Now are you beginning to understand how much of a bad design this thing is? This is so now I can tip it up on edge. I don't know what this crud is here. Looks like there's some crud between some of the pins here. Oh, we got some leakage in here between. Oh, look at this. Look at this stuff. I don't know whether this is the fault or not. Transistors are not shorted, but it looks like there's some. If you look here, it looks like there's something like forming between, like almost like corrosion between these pins. It's between all these transistors. It looks like there's been moisture or something. I'm wondering whether we're getting excessive leakage and this thing's going into shutdown. I'm just going to clean this crap off because the transistors are not shorted, but this thing's going into a shutdown mode. I'm just wondering if it's just dirt related because there's all this crap in here between all the pins on these transistors. I've never seen that, but it's right above where the vents are. So if you've got heat, if you've got moisture in the air, like I'm thinking maybe someone had a humidifier or something and there was moisture or steam in the air, and as the unit was running and it's drawing heat through the heat sink here, you're drawing heat up here, and if there was moisture in the air, it could have. I mean, this just looks like it's like a film that's on here. I'm just going to clean this off. I'll put this board back in and see if it still goes into shutdown. That's a weird, really weird problem on this thing. I'm just cleaning this off with isopropyl alcohol. One thing I've noticed on here on inspection is that these regulators look like they are not good connections. So I'm going to resolder these regulators and check it out. See whether that makes any changes to the way that this thing's operating. It just, the way that it's shutting off like this almost sounds like a power problem. Just the symptom of what it's doing sure sounds like a power supply problem. And we all know how well regulators have been, or solder connections have been on parts that get hot, such as regulators in the past. So I'm just going to redo these connections here. Check some of these fusible resistors as well that feed into these regulators. This one's fed. There's two diodes here, and there's a resistor across here, and there's another one across here. I'm just going to measure these here, see what they, see if they're open. $2K. I think that's a little high. This other one over here, it is that's one, and the other one's off of here. 2K. I think those should be a little lower than that because I believe these are fusible resistors. Those things are a joke. A waste of time. Trusted and true. Where? There's two resistors in here. Let's pull them out. That's one. The other one was what was this one here? Okay, let's just measure these because I think these are burned. That looks like that's burned. $2.8K. I think that's a little high. $3.2K. Red, silver. Is it red or orange? It's like they're like 0.22s. Yeah, those resistors definitely look like they're burned. Why they're burned is a good question. I don't have the exact size, but these ones should be good enough for this. Oh, a little too low. I was wondering why things weren't melting. I think my iron got bumped. Temperature got bumped down to 650. That would explain why things just didn't seem to be melting as well as it should. I'll redo those regulators now that my iron is at the proper temperature. I was wondering why things just seem to be taking a little longer to heat up. I guess my temperature control got bumped. Much better. I'm going to check the other fusible resistors to these other regulators as well. because 2 of them were open. Okay, the only thing I have found that is a little bit out of order on this, still shutting down by the way, is this regulator here is a positive 15 volt regulator, and if we notice when I turn on the power, it's going up to positive 19, almost 20 volts, and then it'll shut down. That's a 15 volt regulator. This is a negative 15 volt regulator. This is a 5 volt regulator. The negative 15 is performing as it's supposed to. If I can get in here with my probe, I can flip the power on. Minus 15. So it's working. The positive 15 is going high. Now whether that's shutting the receiver down, I don't know. Could be. This is a 5 volt regulator. This one's working fine. I don't know why those resistors were open, but they're in the 5 volt supply. I'm trying to angle this meter so you guys can read it. Okay, so this should be the minus 15 volt supply, which it is. And the next one over should be the plus 15 volt supply. As you can see, the plus 15 supply is going, where is it here? That's the wrong way, that's ground. This should be the plus 15 supply. As you can see, it's going to plus 20. So the regulator itself here is probably shot. The only reason it's going to that high voltage is either A, there's no load, or B, the regulator shot. And I'm thinking what's happening on this is that the unit is going into an overvoltage shutdown because the regulator is not functional. So I'm going to have to get a new 7815 to try on this thing, as I don't have one. Although I could probably just disconnect the 15 volt source down here and supply it with an external 15 volts. And that would certainly tell me whether the receiver is going into shutdown due to overvoltage. That might be an idea, because there's a strap down here that I can cut, and that would allow me to supply an external 15 volts without having to go and buy a regulator. The problem I've got is that, of course, the only day of the week that I can get in to the supplier is on a Friday or a Saturday. So today's Monday. This is going to be sitting here all week if I don't try to cut into that supply and supply it with an external 15 volts. So let's try that. Let's just cut this and see. That way, if I can set it to 15 volts and the amp turns on, then we know that the problem is that it's an overvoltage. You see, and why an overvoltage would cause a problem like this is that the positive and negative 15 volts are going to supply an op amp. And if your voltage is a difference like that, then it's going to affect the linearity of the output signal, because of course the output signal is based on a positive and negative supply of the same voltage. So that could certainly be why it is shutting down, is that the CPU is detecting that the voltage is unbalanced and it's shutting it down. That's kind of what I think is happening anyway. I'm not 100% sure, but I think that's probably why it is going into shutdown before the speaker relay kicks in, is because it's detecting that there's a voltage imbalance. Another reason would be if we had an output that was shorted, but I went through and checked all the outputs and none of them were shorted. I've now attached a wire that I can feed with plus 15 volts. We'll feed that in from my external power supply. So I'll set that for plus 15 and we'll connect it. Take my supply down to 15.1, 15 volts. There we go, 15.0. And I'll limit the current down to, a couple hundred milliamps, maybe an amp. There we go. I'll limit it down to, I think the regulator would handle about 3 amps. So we'll ground one side here, and the other side, I'm just going to get ready to power this thing up, and we will feed it with 15 volts. So here's the meter. So if I test the voltage here on the meter, we'll see that I've got 15 volts ready to supply to this wire here. As I turn on the power, I will connect 15 volts and see whether the unit still shuts down. So I got 15 volts to it now, and it doesn't shut down. It's not, and there's the power relay. We have a 15 volt regulator problem. Let's get some sound out of this thing. Then I can prove it that it's the regulator, and I can go and pick that 15 volt regulator up, and then you guys know what goes wrong with these Denon receivers. So let's hook up some speakers so that I can prove that that's the fault. You see, then I can publish the video knowing that all I got to do is go and change that, and I can do that on the weekend, and then I'll have a very happy customer who have a nice receiver that he basically got for nothing. I wish people would leave me nice receivers like this. Oh, wait a minute, I've got a few around here, I just have to fix them. Okay, we're ready to power this up. So all I gotta do is basically connect the negative lead to the chassis at the same time as I power the power switch up. And now we should have our 15 volts. I got the volume turned down to nothing. And we turn on some speakers. And I probably gotta tune something in on the radio here. And we figure out how to do this. Oh, speakers. Speakers on. Tuning. I might have to put an antenna on this thing. I will have to put an antenna on this thing. Well, you know what? Let's just plug some sound into this thing through the auxiliary input on the front. We'll select V auxiliary. I think it's that one. Okay. Yeah, I don't have an FM antenna plugged into it, and that would be why it's not tuning anything in. But hey, here's my power supply running 15 volts. As you can see, 340 milliamps is what it's drawing. Now, to say that this was an easy one to troubleshoot is an understatement. It was not a very easy one to troubleshoot, primarily because this is such a difficult design to work on when you've got to take everything apart to get the board out to do anything. I had a couple of resistors that were open here, a couple of fusible resistors that were open. Why those were open, well, they weren't open, but they were really high. They went to like 2.2K. Why they went to there, I don't know, but they are in that regulation circuit. They're actually for the 5 volt regulator. The 15 volt regulator had failed and gone to 20 volts. That was causing a voltage imbalance because you've got a negative 15 volt supply here and you've got a positive 15 volt supply there. That was causing a voltage imbalance to the op amps, and obviously the system control, the microprocessor was checking the voltages and finding that the voltage was out of spec and was shutting the unit down. Feeding with an external power supply allows the unit to operate, proves that the rest of the receiver is okay. So now all I need to do is get that part, and this one will be fixed. So I don't need to, I'm going to finish the video off now because we know the receiver is done. It gives you guys something to watch. And we'll do a follow-up when I get the part, because I'll be leaving this thing in pieces. I'm just going to set it aside so that I can work on some other stuff. But I'll be leaving this thing in pieces until I get the part. And then we'll do a follow-up video, putting in the new part, and putting it all together and testing it. We got it fixed. We know the problem. Well, we don't have it fixed. We've diagnosed it. We know the problem. We've got it working. Thanks for watching. We'll catch you in part 2 as soon as I get the part for it.